This is OCR 21st Century Science P2. Lesson 3, we're going to look at communication, particularly how we can use EM radiation to communicate, and we're going to look at the idea of analog and digital communication and analog and digital sources. In addition to that, we'll look at how we can use light waves to communicate. So let's start with which part of the spectrum we can use. So firstly, back to our EM spectrum from previous videos, we can use radio waves, we can use microwaves, and we can use visible and infrared waves for communication. So radio waves are what's sent by radio and TV stations, microwaves for satellites, and we can also use infrared and visible radiation in some things called optical fibres. But before we do that, we're going to look at the idea of why we use radio waves and microwaves. So radio and microwaves, they're particularly good because they can travel long distances and they can pass through the Earth's atmosphere, therefore enabling us to send signals through the air over significant distances. So radio and microwave photons can pass through the atmosphere, which is why they're used so much. Now, increasingly, our communications and our lives are digital. So we're going to have a look at the difference between analog and digital communication and analog and digital devices. Now, my voice is an example of an analog wave. If I were to analyse the sound waves, then I would see a smooth, continuous wave as a trace. Now, digital devices deal with turning these analog signals into a different type of signal, one which has only two states. It has an on state or one state, or an off state, a zero state. So this difference between analog and digital is quite stark, and the ability to recognise the difference between digital and analog signals is key, but I think it's fairly obvious. Now, the reason that everything has gone digital is because digital has a distinct number of advantages over analog communication. Now, if I send an analog wave through the air, when the analog wave arrives, it will have combined with other signals, stray radio signals, whatever they might be from space, cosmic rays for example, and the wave that arrives will have extra information encoded upon it. I don't know if you can see the difference there. This is a smooth continuous line, whereas this one is the same shape but it's got these extra things on it. Now the problem with that, and we call this stuff noise, is that interferes with the quality of the signal. The difficult part is getting rid of the noise. Because it's such random nature, I don't know particularly if that little bit of extra information on there is noise or whether it's part of the original signal. So in an analog signal, noise is very difficult to get rid of. In fact, it's impossible. All you can do is amplify the signal to make it bigger, but it's still just as noisy because you amplify the noise. Digital signals, however, are much easier to deal with in terms of noise. If I send this signal, you can see there's also noise on my digital signal. But when I look at my digital original signal, 0, 1, 0, 1, 1, 0, even though the signal that's arrived has got noise on it, it's still discernibly a 0, a 1, a 0, a 1, a 1, and a 0. So even though both analog and digital signals arrive with noise on them, the fact is that my smooth signal has now been corrupted, if you like, with this random noise. My digital signal has been corrupted by this random noise, but the fact is I still know what is 1 and what is 0. So effectively, I can clean up that signal using a computer and turn it back into the perfect signal again. Now the key here is the idea that because there's only two states to be in, then it's fairly obvious what's a 0 and what's a 1, and therefore I can regenerate that. So the first advantage of digital is that the complete absence of noise. And if you use a mobile phone, it doesn't matter if the person's in the next room or on the other side of the earth, as long as you have a good signal where the noise isn't too much, the noise can be completely removed and the sound is perfectly clear. The other advantage of digital communications is in terms of size. Now, digital devices such as iPods or MP3 players store music, which is an analog signal, in a digital form, and that can be compressed and reduced and stored in a small space. So storage of a lot of information in a small space is another vital positive of digital communications. The other reason it's so popular is it's versatile. If I have a memory stick, I can store music, videos, pictures, documents, books, audiobooks, etc., all in the same digital format. Whereas in an analog, I would need records or cassettes to store music. I would need VHS videos to store video. If I was going to store a book, then that would be a typed manuscript or have it on paper. So versatile. And the last advantage of digital is that you can manipulate the data. Now, cameras used to contain film, and that film would be taken to the chemist to be processed, and you'd be given your photographs, and you couldn't do anything with them. Nowadays, obviously, you can take as many photos as you like. You can edit them as you go on your phone. You can chop things out, change the color, change the brightness. That's all because all the information is encoded of each pixel, each picture element is a number, and therefore you can change those numbers quite easily because that's what computers deal with. So you can manipulate your data, change colors and edit things very easily. You can store lots of different types of information on digital, and you can store lots of information in a very small space. Key for communication is you can completely eliminate the noise on the signal because you know the difference between a 1 and a 0, even if it's a noisy signal.